Hi, and welcome back to another how-to video brought to you by Tim Unscripted. So, a little bit of a different format. I was offloading some files from my local hard drive to OneDrive, and that's kind of where I run Camtasia most of the time. TechSmith, don't get angry at me. I know, the whole proxy thing. I got it. So, subsequently, I decided to record this how-to video using one of my other favorite AI-based tools, TypeScript. So big shout out to TypeScript for giving me the capability to do rapid recording and editing on the fly. I want to pick up on where I left off, which was it was a quick OpenClaw demo specifically around my BuddyBot being tied into Telegram. Well, I have shifted. I shouldn't even say shifted. I pivoted. So in this particular video, go back to the other ones to see the whole OpenClaw thing and some of the struggles that I went through just to get the System 76 laptop up and running, running Rust Desk server, all of the things. I won't bore you with the details. Each one of those is about a half an hour long, plus a 15-minute where I actually show you what BuddyBot was able to do as far as the responses are concerned via Telegram as an OpenClaw instance running on System 76 on Pop OS. I've been doing a little bit of research. Well, I do a lot of bit of research, so this shouldn't surprise you. One of the things that came up, and I mentioned it in a prior video, was the fact that there is another agent called Hermes. So I went out and this morning I did what any curious learner might do, which is kind of go, okay, so what is the difference between OpenClaw and Hermes? Well, number one, OpenClaw is an open source project, whereas Hermes is actually sponsored by Nous. And it's been recently released, so this is something that is kind of new and cutting edge to the market. And so I did ask the obvious question, research Hermes and Nous, not knowing that it's not Nous, it's Nous Research, and return the latest comparisons between it and OpenClaw. And so I wanted to walk you through what this is about. So two different ways of doing things as far as agents are concerned. And this is key. So OpenClaw is a framework and not a model. And it's an open source TypeScript, Node.js, blah, blah, blah thing. And it's an ecosystem. And that's great. Like I said, this is a project. This is out there on GitHub and doing great things. And so this is one of these neat situations where we've got two different approaches going on. One that is more, I would say, privately focused versus one that is more publicly focused. And I like this. And by the way, so my tech research space, and Simplexity is just the version or Perplexity that's available on Linux. Don't ask me about the packaging. Okay. Suffices to say, one of the things that I do is I get whatever works going on Linux. So I've got a persona set up when, I'm doing tech research. It understands that I am, by and large, the software developer playing, or the actor playing a software developer on social media. So this is just kind of a play on this whole persona that I've got going on that, and in fact, I get paid to do professional development. So I'm not even an actor anymore. Anyway, so Hermes is an agent that's like a character-driven spin-off series. OpenClaw is the big crossover in the cinematic universe that wires every character and platform together. And I like that. So Hermes is a very discrete versus OpenClaw, which is an entire ecosystem of things. So here's one of the things that I also wanted to make specific mention of. Hermes is Python-based, and it's tightly coupled to Nous, Hermes, and the derivative models. Those models, and I won't get into all the details, those are based on Llama models, meta-created models that have been fine-tuned to work in their environment. And of course, language and stack is very different for OpenClaw, TypeScript, and Node.js, orchestrating many agents and tools and skills defined manually and composed into workflows. I like this, though, with Hermes, and I'm going to show you, by the way, that it is model agnostic. It focuses on building learning loops and layered memory. So whereas when we think about OpenClaw and its agents, they're not constantly learning. They're kind of fixed. Now, the memory file allows them a degree of quote unquote learning. You can build skills in as well. I would say it's a lot more hands-on than necessarily Hermes is, which is something that you should evaluate. And here's the kicker. So this is probably the more important piece. OpenClaw can run on fairly lightweight hardware. It's not great. In fact, none of these things are really great on lightweight hardware. These are, by and large, because of the models, not because of how the software that interacts with the models is created, but the models themselves. Models are just GPU intensive. Until we figured out a better way to process the ins and outs of these models, we're going to be very reliant upon GPU memory and the associated horsepower that make them work. Trust me, I have a hard spot about this, but I'm in no position to influence a different outcome. I would always go back to and encourage you to read Karen Ho's Empires of AI, which is an excellent work, kind of giving you an idea of where the decisions were made with generative AI in that publicly facing ChatGPT world, and the intentionality of things. Bigger is better. I'm going to reserve my opinion on that. I have a repo on GitHub that differs with the bigger is better's opinion. So subsequently, I'm not going to bore you with all the details on this, but I wanted to point out that they are distinctly different in the way that they are approaching agents and the use of agents and working with tools. So that being said, and one of the things that is worth mentioning here is the fact that all of this is only as bad as it's ever going to be at this point, which brings me to why I decided to take and rewire some of the pre-existing things that I had running for OpenClaw on Linux to point to Hermes, which of course, being a little bit selfish and not self-aware, I just did this because I could do this. But more important, because my how-to videos are really out here to show you that, it's not, the technical difficulty is fairly low. You don't need to have a highly technical background in order to make all of this stuff work. It's just a willingness to continue to learn and be curious about these tools. So one of these things I wanted to point out is that I've specifically, and again, this is me nerding out a little bit and trying to figure out what might work versus what might not work. I nerded out and subsequently spun up this instance of Hermes, and Hermes gave me hey, by the way, you need to have at least a 64,000 token context window by default, which didn't work with Gemma 3 Nano when I initially installed it. Fix that. I did the research. You can do that too. You can actually make all of this stuff work by adjusting the context windows via some scripts. So subsequently, what I did do is I decided that I was going to take and try an experiment again. So this has been up and running for 18 minutes now. And so what we're going to do is we're going to do a little test. In this test, again, to show how hardware intensive it is really designed to go from the time of when this prompt goes in, and we're going to just type it in real quick. So when this prompt goes in to when it actually finishes. And I'm already almost 10 minutes into the video. Oh, wow, my API call failed. So that's even better. All right. This is kind of designed to make me look bad from time to time. So I'm going to go off camera for a moment. I'm going to fix this whole API thing. By the way, I've got all of this in my research because I've actually made it work. And I'll show you some screenshots for how long it took in one particular instance with a different model. So I will be right back after a few minutes here and resume this experiment. All right, so I'm back. And what I've done here is I've actually reset the model because so two things actually. I set up a generic endpoint instead of localhost. So this has an IP address assignment. It seems to work better. And it helps to avoid some of these errors that we saw initially. And as well, you can see my list of available models. And so it took over 20 minutes for GLM 4.7 to run or to generate a response to the simple 2-letter word hi, which is exactly what failed up there at the beginning. We're not going to worry about the Gemma models, mainly because the bottom line is that certain models don't have the ability to do tool calling. Hermes does appreciate tool calling. It's just one of the things that's embedded in it. So to avoid throwing up any more errors, what I did do is I put quencoder in place just to show you kind of where we're at as far as the speed of response. Now, mind you, this is going into the model and using the model's inherent capability to do a lot of different things, include logically choose what tools to use based on the prompt. So while OpenClaw is faster from the standpoint of basically it's not transacting or performing work directly in the model, Hermes, on the other hand, is. And so there's a lot more communication going on. So for lack of a better way of describing it, it's very verbose. And so there's back and forth. I did a lot of research on this, and I've actually got this terminal window open to show you kind of the transactional things that are happening behind the scenes that we don't necessarily see in the terminal interface occurring. So what I'm going to do is I'm going to kick up another instance of Hermes. So I reset it, or I shut it down. I'm basically rebooting it. And you can see now Qwen3 Coder is loaded up as the default model. So here we are. Okay, 13 seconds and we're off to the races. So you can see it's transacting here, waiting for server to become available. 21 seconds. It's synthesizing. You get a real-time feel for how heavy this is just by watching the seconds and the minutes and the hours as far as the counters are concerned. And we're going to see some degree of transactional activity over here in the logging. While this is occurring, and of course we can keep our eye on all of this, I wanted to point out what prompted me to go this direction with creating more visibility. So you can see, my prompt here was, hey, GLM Flash has been deliberating for over 2 minutes just on that simple word hi. So I asked, well, what's going on? Why can't I see anything happening here? And it gave a really good, solid answer. And of course, it's the key for me in all of this is just being able to orient my thinking and set my expectations correctly when I'm using any of these tools and models. This is just one of those deals where I would say a lot of it is learning. Okay, and now we're at 2 minutes, so you can see that this is quite a process. Let me take and flip real quick back to our terminal to see if there's any more transactional activity. So the Llama runner has started at 6 seconds, which is good. But of course, we don't have anything additional. So this was the initial thing that kind of kicked off. Llama runner's running now. But these are the things where you've got to think through the applications and tooling, because they are going to be the thing that determines your overall experience and how effective things are for you. So if you're speedy and you want work to be done by your agents, then OpenClaw may be your route. And I'm saying this, if you're doing it lightweight on hardware that isn't gaming hardware certainly gives you a distinct advantage from the standpoint that it's designed for high computational loads, both on the CPU as well as the GPU. Neural processing units will come in at some point here. I know Apple Silicon is really great about leveraging multiple cores. Their integrated design and fabrication is phenomenal. This is the reason why there's a lot of people who actually prefer working with M-series hardware rather than AMD NVIDIA combination hardware. I don't blame them, although AMD's AI hardware, based on my experience, is pretty performant. That being said, there's still trade-offs and bottlenecks. With Apple, you don't get the option of upgrading your RAM, nor do you get the option of upgrading your GPU. You are stuck with whatever's soldered on the board. Whereas if you buy a gaming ring and You buy a high-end processor that happens to be a system on a chip where you've also got neural processing cores co-located and a certain amount of RAM on that system on the chip. Then you may be better suited and may get better life out of your hardware in the long run by Apple. This has to be, I would suggest, an intentionally well-researched choice. I do a lot of research when I'm looking for what additional hardware I might add to my home lab. And of course, going back to that whole AMD or Intel piece with the gaming hardware, you do get the option of upgrading your GPU. You do get the option of upgrading your power supply. And I'm saying this from the standpoint of a semi-custom build. If you're talking about hardware coming from major manufacturers, the likes of which, you know the names, I don't need to repeat them, but you go a little bit to I would say the edge of that, where you've got semi-custom builds where you can buy them right off the shelf, pre-configured, 32 gigabytes of RAM, an NVIDIA 16 gigabyte video card, in addition to a pretty close to top end AMD or Intel processor, air-cooled, liquid-cooled. These machines are really designed to have a better upgrade life cycle and run longer. You could go all the way to the extreme, and I've mentioned this in the past because I'm running on a System 76 machine. You could do a highly custom build from a company like System 76 if going the Linux route doesn't bother you. It bothers a lot of people. A lot of people don't want to go off of the Mac OS. They don't want to go off of Windows. Linux gives you this high degree of flexibility. It can be daunting at sometimes because some of this is actually the whole command line driven thing. You've got to be okay typing in commands rather than hitting a GUI to make your stuff work from time to time. Not a bad thing. It's just a matter of personal preference. There's no right, there's no wrong. It's just different. And I wanted to check in here. So we're still at 6 minutes. Let me flip back over to our transactional terminal. So we still got the llama running. And I'm showing you this because this is a much more intensive way of running agents via Hermes. So part of this goes down to, oh, by the way, and you'll see here in the research that it's not an issue with the software. It's not an issue with Hermes. In truth, it is an issue where, guess what, Tim? You're trying to run this thing on hardware that it just wasn't designed for. And because you don't have a dedicated GPU, you're using just the GPU that is associated with the overall system board, and the combination of a mobile GPU in addition to your CPU, it's going to lag. It's going to be slow. And I knew going into this, it was potentially going to be painful. So I was under no illusions. What I wasn't prepared for is the amount of time it would take to come back with its first response. Here's the oh, by the way, and here's my logs, because I already did this. I'm just kind of recreating the exercise that I did below. And here's the point, which is, oh, by the way, you've offloaded 0 layers to 48. You have no usable GPU for this model, so everything is running on CPU. Oh, well, there you go. Bing, bing, the light goes off in my head. And by the way, I deliberated between GLM and Quinn because I thought that GLM might have been faster because it was hanging on Quinn initially. Oh, heck no. It is this whole CPU GPU combination. And so this is slow. It's not stuck. I know that because, of course, I ran a bunch of things. In fact, I did this side by side with my terminal. In fact, this is probably worth actually demonstrating to show you the performance. So what I'll do is I've got another terminal window here that I'm going to throw up, and I'm going to go, oh, Llama. run when help Quinn free coder coder dash what are we calling this? 64K latest. Watch this. So we're 10 minutes in. 10 minutes in. Still have no response. Now, this should be a lot faster than what we're seeing over here with Hermes. I'm not guaranteeing it will be a lot faster, but it should be a lot faster. Now, mind you, I've effectively crushed this thing because I've got one set of threads going over here on the Hermes side in a terminal window, and now I've spun up a different set of threads over here going straight to Llama and Llama CPP. And, you know, it'll be funny if Hermes actually finishes faster than Llama CPP and Llama. But, you know, stranger things happen, right? It's just one of those things. In fact, I guarantee you, I can kick off a third terminal window, which will really be a kicker for everybody. That will show how fast I should say the marked difference between Quinn Coder and the GLM model. So, Llama, list. And what I'm going to do is I'm going to go copy this, copy that. Llama. That's not going to work. Run. Control-Shift-V. This should spin up fairly quickly as well. Now, mind you, I've probably hit the maximum capacity of what I can, how many models I can run simultaneously on this machine. So if it crashes due to a thermal event, look at that. We're already starting to generate tokens and get a response out of GLM 4.7. So just to give you an idea, we're 12 minutes in here. We're probably a minute and a half to 2 minutes in here. We've actually got GLM 4.7 Flash starting to think through a response. And I guarantee you Flash is going to beat both of these other two. And these how-to videos are really designed to kind of give you a behind-the-scenes look of what frustrations you may actually encounter while you're trying to do this type of work yourself. This is not to discourage you. I'm trying to give you some sort of realistic level set so that you don't walk into these things blindly. And I'm saying this now that this is nearly half an hour into the video. It's over 25 minutes into the entire recording. And all we've got is deliberation. And we haven't even gotten a full response yet to the simple 2-letter prompt, hi. And let's just, for good measure, I want to pull up the other terminal window, which is the one. This is probably, yeah, that probably wasn't a good idea. So that one and number 2. So yeah. Oh, hold on. So now we've got, I think where I threw this for a loop is the fact that I might not actually be tracking, given the other 2 instances that I spun up, the actual response here by Hermes. Suffices to say, well, look, here we go. I was right. GLM came in first as far as finishing, and it started last. You know, this is one of those things that, you know, I do have to poke a little bit, because it's like you don't know. You really don't know sometimes what is going to get the job done versus what's not going to get the job done. And for me, this is part of the fun. This is part of the experience. At almost 15 minutes in, we got nothing. We can't see a darn thing. At somewhere well below 15 minutes, still nothing. Over here, hey, we actually got a response. So I'm gonna type by just to show you that, you know, this is, I don't want to say it's a crapshoot, but oftentimes I know I am left scratching my head going, okay, what did I do wrong here? I know wiring these things up can be difficult, especially since I'm really not familiar with any of how this works. This is just one of those crazy things where I'm just like, okay, yeah, maybe I did something wrong here. I don't know. The funny thing is that the logs don't indicate that I've done a darn thing wrong. In fact, given the fact that when I spun this up initially, it said, oh, by the way, you're kind of jacked on your tool calling and your API connection failed out, due in no small part because I didn't put the IP in. These are the things that you live and you learn as you're going along. That being said, what I don't want to do is continue to bore you with pontification. Really what I wanted to show you is that between OpenClaw and Hermes, give yourself a chance to do your own homework, your own research to figure out which one might work better for you as far as agents are concerned. Consider your operating system, your hardware, what you may or may not be able to offload. Again, this is a laptop. I had no expectations that any of this was going to move fast. I just wanted to demo the environment because my concerns with OpenClaw, and I think similarly so with Hermes, is I didn't want it to touch things that I actually cared about. So I've got this stuff running on, we'll say a lab laptop, just to be able to do the demonstrations, you know, pulled in via Rust Desk. And you can see that because I've got my Rust Desk instance running here from my Corsair production machine. So I am going to Control-C out of this, if this actually allows me to Control-C, which is going to stop that. I'm going to go /by. I'm going to exit that. I'm going to also come over here and interrupt this. The intent in all of this was just to kind of give you an idea as to how this may or may not work for you on your hardware, in your home lab, and be able to give you a better, kind of more informed way of making these decisions. In the next video, I'm actually going to take and show you some of the places where I've done research. Okay, you've seen that I do research with Perplexity, but guess what? I go a little even further. So I'm going to wrap this video up. Once again, thank you for joining and making it to the end of another how-to video brought to you by Tim Unscripted, and I will see you in the next recording.